Hey, what's going on, guys? Let's see how we can find the electric field created by these two charges in this location. Let's see how we can calculate this one. So first of all, we have to know which one going to give us the electric field, right? Like this one E1. So you know the for the plus, the electric field will emits away from it. So that's why in this direction, that is E1, and E2 is this one negative charge. For a negative charge, the electric field will emits toward the charge. So that's why this one is in this direction. And if you notice that if I take this, so in this case, this is not in straight like a straight x-axis or y-axis, right? So this is going to have two components. If I take y components, what's going to happen is it will cancel each other. Let's draw in our green color. So this y component is going to be something like this. This is going to be something like this. Since theta is equal, it means distance is equal, and also the charge and r is equal. Like this is Pythagorean theorem. A is equal, x is equal, r also equal. So the charges are going to be equal. So it will cancel each other in the negative direction. So if I calculate the x-axis, that will give me the x-axis resultant in x-axis. That will give me the electric field in this location right here. So let's see how we can calculate that one first. So we are going to use E is equal to kq over r square equation, and in this case E1x. If I want to calculate E1x, if this is theta, this is also going to be theta, right? This is making this angle with horizontal, so this is also going to be theta. If this is theta, this is also going to be theta. You can think as C shape. So this is also going to be theta. So I can say E1x. If we want to calculate E1x, I can say E1x is equal to E1 cos theta, right? E1 cos theta, and therefore E1x is going to be kq over r square. E1 is kq over r square, right? K. Let's take E1 is kq over r square. So kq over r square, then this is E1x we are calculating. E1 is kq over r square. E1x is kq over r square cos theta, right? So here cos theta is going to be, here if I take this theta, cos theta is adjacent to over hypotenuse. So this is going to be, adjacent is here x. So x over r. So that's going to be our kq. So kq times x in this bottom. Let's put capital R right here. This r is equal to a square plus x square according to Pythagorean theorem. R square is equal to a square plus x square. So in the bottom we have capital R square, so we can put like a square plus x square right here. And here we have x on the top. And then also we have cos theta is equal to x over r, right? Cos theta is equal to x over r. I plugged the x already, so we are going to have an r here, right here. So r is same thing. R is like a square root of a square plus x square, right? So this is our r. So I can also combine this one with this one. So that's going to be 3 by 2, because 1 plus 1 over 2, that's going to give us 3 by 2. So the bottom power is going to be 3 by 2. So we can write kq x a square plus x square power 3 by 2. So 3 by 2, and this is our E1x. And to calculate total electric field, I have to add E1x and this E2x together. E2x together, and if I add, and you know, the magnitude is going to be same, because since the distance is same, angle is same, height is same, everything is same. this is going to be equal to e to x2. So we can simply put a 2 in front of it. 2kqx over a square plus x square power 3 by 2, right? This is our electric field right now. Then what I can do is, we know the total distance is d, x is half of this, so we can replace x as d by 2. So here we are going to have E is equal to 2kq times d by 2. In the bottom, it's going to, instead of a, I can plug, instead of x I can plug d by 2. So here we are going to have a square plus d by 2 square power 3 by 2. And the final answer, if I go and write this one into vector format, this is going to be in this direction, kq d. Since we have 2 right here, 2 cancels, so we can just put kqd over d by 2 square plus a square power 3 by 2 in the x direction, because all of them are in this direction, right? So in this x direction, and that's going to be the final answer for this question. I hope you guys like this video. See you next time.